Urgent. In late June 2026, more than 1,300 configuration records in a production database locked up simultaneously. A ransom note appeared on the system, but the logs showed no human user had been active during the breach. This was the work of Jade Puffer, the first documented ransomware attack to be run end-to-end by an autonomous AI agent. In the past, a ransomware campaign required a coordinated team of specialists. Human hackers had to manually probe the network, steal credentials, and pivot between servers to find the most valuable data. Jade Puffer executed more than 600 distinct payloads without a human at the keyboard. It proves that an AI agent can now navigate the entire lifecycle of a destructive campaign alone. The human role in the attack has been reduced to a single decision. An operator just selects a target, establishes the basic infrastructure, and starts the agent. Once active, the Jade Puffer agent swept the environment for cloud credentials, bypassed security firewalls, and forged authentication tokens to access the production database. In the final step, the AI generated a unique key, encrypted the records, and deleted that key immediately. The agent then generated its own ransom note, leaving the data permanently unrecoverable, even if the victim paid. The barrier to entry for global cyber warfare has collapsed. The cost of running a sophisticated, automated campaign is now essentially the price of an AI API subscription. 1 week after the Jade Puffer disclosure, the government of Alberta began the first documented provincial deployment of an AI model for cybersecurity. They used Claude, a frontier model from Anthropic, to scan their systems for vulnerabilities. This illustrates the core defensive thesis. When attacks move at the speed of an algorithm, human security teams are too slow to react. The only tool fast enough to defend the network is another AI. There is evidence this works. In early July, an AI model auditing a common web proxy server discovered a critical memory leak, a vulnerability that had existed for 29 years without being noticed by human researchers. By mid-2026, the tactical execution of cybersecurity had reached a tipping point. While humans still set the overall strategy, the move and countermove of a breach now happen at the speed of software. But this defensive strategy faces a logistical hurdle. A government security team scanning its workflows moves linearly, while the attack surface is expanding in every direction. This timeline shows how the threat landscape is shifting. In a single 24-hour window this July, 5 frontier AI models launched to the public, including GPT 5.6 and Grok 4.5. Simultaneously, cheap, open-weight models from China are plummeting the cost of high-end intelligence. The math favors the offense. Defensive AI is a constant game of catch-up, while offensive tools are now cheap, globally accessible, and scaling at an exponential rate. Humans are attempting to govern this chaos through traditional diplomacy. In Geneva, 169 countries met for a UN global dialogue to try and establish basic guardrails for AI development. In the US, regulators are focused on an August 1st deadline for a new NSA security framework, a desperate effort to draw a line in the sand for the next generation of models. There is a mismatch in velocity. These government frameworks are the product of months of deliberation, yet the market they are trying to regulate can be transformed by a single software update in an afternoon. Policymakers are drafting rules for a landscape that changes every 24 hours. The government is moving at a human pace, while the technology aims to contain has transitioned to machine scale.